So in this video, we are going to solve problems from exercise 7.3, which belongs to chapter number 7, triangles. So we're going to look at problem number 1. Let's see what the problem is. Okay. So triangle ABC and triangle DBC are two isosceles triangles. So let's try to trace them. So this is triangle ABC. Okay. And we have another triangle DBC. So this is DBC. Okay. Both of them have the same base BC. Okay, D, B, and C. Okay, so these are the two very important piece of information is two isosceles triangles. Both of them are isosceles triangles. Okay, on the same base BC, and vertices A and D are on the same side of BC. So A and D are on the same side of BC, and both these triangles are isosceles. What does that mean? If they're isosceles triangles, their two sides are going to be equal to each other. So I'm going to erase this and mark that point. Okay, so AB is equal to AC, okay, and BD is equal to CD. Okay, that's an important point we are going to need in the problem. Now, if AD is extended to intersect BC at P, so this is the line AD which is extended to intersect BC at this point P, show that. And 1, 2, 3, 4, there are 4 things to be shown. So we'll see them step by step. Let's remove this as well. Okay, so first thing that we want to show is, let's focus on that, triangle ABD. So again, let's highlight it to get a good idea. ABD, this triangle, okay, triangle ABD is congruent to triangle ACD. So ACD is this triangle ACD. Okay, now focus on this figure. Let's try to zoom in a bit. Focus on this figure. So this triangle ABD and this triangle ACD, AB is equal to AC, okay, because this is isosceles triangle. Then BD is equal to DC, because again this small triangle is also isosceles triangle, and AD is the common side. Okay, so by side test SSS, these two triangles are congruent to each other. So I'm just going to quickly make a note of this point. In triangle ABC and triangle ACD, okay, we have AB as equal to AC, first point. Then second point, BD is equal to CD. Okay, both of these sides are equal sides of two different isosceles triangle. The first one is this big triangle ABC, and the small one is DBC. Okay, but anyway, that doesn't matter. This is equal to this, and this is equal to this. Okay, and then the third thing is AD is equal to AD. AD is equal to AD. Why? Because it's a common side. Okay, so this is not triangle ABC, this is triangle ABD. That's a mistake I have made. Let me just make this ABD. Okay, AD is equal to AD because it's a common side. So since all these three sides of these two triangles are equal to each other, we can say very confidently by, okay, by side test of congruency, of congruency, okay, we have, or we can say that triangle ABD is congruent to triangle ACD. Okay, quite simple and straightforward. It's a side test application. So first point is done. Okay, now next point is triangle ABP is congruent to triangle ACP. So once again, let's quickly try to erase this. Okay, and try to trace that triangle. First triangle is triangle ABP. So ABP, this triangle. Okay, and second is ACP. So ACP, this triangle. These two triangles are congruent to each other is what we have to prove. Okay, now before we move to the proof, we have shown that ABD is equal to ACD. Okay, that means all the three sides and all the three angles of both the triangles are congruent to each other. Therefore, we have, from this congruency, we have angle BAD, okay, as equal to angle CAD. Okay, I'm going to trace that angle with a different highlighter. So BAD, this angle, okay, I'm going to just write BAD is equal to angle CAD, this angle. So it's become quite messy. Let's get rid of everything. Okay. So now let's focus on this angle BAD. So BAD is equal to angle CAD. these two angles are equal to each other. Why? Because we shown that these two triangles are congruent to each other. This piece of information is important to prove our next set of result. So I'm just going to erase this. Okay, and in order to use the same figure, I'm just going to put a yes. Yes. So now let's come back to our original second point. So just to quickly revise, sorry, not to revise, to restate, we have to prove that this triangle ABP, okay, this triangle ABP is equal to this triangle. Okay, so let's move this a bit. Yes, that is what we have to prove. So first thing, we have this side as equal to this side. Okay, AB is equal to AC. Why? Because it's a part of a isosceles triangle. So point number one, we have AB as equal to AC. Why? Because those are the two congruent sides of isosceles triangle. So that becomes our first thing. Second thing, we have AP as equal to AP. Okay. Why? Because they are the common side is the same side. And the third thing we have is this point. Okay. This thing, that the angle BAD is equal to angle CAD. Okay, and thus we have a side angle and the side SAS test. By using SAS test of congruency, we can say this big triangle ABP is equal to ACP. So that's what I want to do here. Okay, so let's zoom out a bit. Yes, so again using SAS test of congruency, we can say the triangle ABP, okay, is congruent to triangle ACP. Okay. Okay, let's write it a bit better. Okay, triangle ACP, and that is what is the second point that asks us to prove, and I'm going to mark it done. So we have proven that ABP is equal to ACP. Okay, now once again, before we move to the third point, since ABP is equal to ACP, we can say that, let me use a highlighter, we can say that BP is equal to CP. Okay, this BP is equal to this CP because they are the corresponding sides of the two congruent triangles. Okay, so we have, so I'm just going to make a point here. Okay, okay, uh, yes. So from this congruency we have, so once again I'm going to note it down. Therefore we have BP as equal to CP. Why? Because they are corresponding sides of the congruent triangles. Now again, the reason I'm noting this point is because we're going to need it in the next third point that we want to prove. So once again, I'm just going to cover these things and make space for the next. Yes, move it a bit. Okay, and once again we are going to erase this highlighter thing. Okay, and okay, fine. And now let's come to the third point that we want to prove. So this is our focus, third point. Now third thing we have to show is AP bisects angle A. So this line AP bisects angle A. This is something which I have already proven because we showed that this angle is equal to this angle when these two triangles are equal to each other. So it bisects angle A, that's very obvious, as well as angle D. So we want to show it bisects also this angle D. Okay, so that we are going to show, let's come here, that we are going to show by proving that this triangle, okay, this triangle is equal to this triangle. If I prove, so I'm just going to note it down, to prove triangle BDP is congruent to triangle CDP. If I prove these two triangles are congruent, then I can say this angle is equal to this angle, which means angle D is getting bisected by this line AP. Okay, how are we going to do it? So, okay, this side is there, this, okay, one side will be side test. So we have, so I'm just going to say we have point number A, we have BD as equal to CD. Okay, why? Because this is an isosceles triangle, it's already given. So BD will be equal to CD. That's the first thing. Secondly, we have DP is equal to DP because it's a common side. It's the same common side between the two triangles. So these two sides are also equal to each other. And the third point is the point we are going to take from here. Yes, this point. Okay, we showed from the previous proof that BP is equal to CP. So BP is equal to CP. That's my point number 3. So I'm just going to write here BP is equal to CP. Okay, and once again from SSS test. So I'm just going to make here by side test of congruency of congruency, we have triangle BDP, sorry, triangle BDP as congruent to triangle CDP, okay, by SSS test, and therefore angle BDP is equal to angle CDP. This is important. Okay, this is what we want to show. Angle BDP is equal to angle CDP. So let's zoom in here. Yes, and let's try to remove this highlighted thing. Yeah. So this angle, okay, this angle BDP is equal to angle CDP, which indirectly means that this line AD is bisecting this angle BDC, and that covers our third point which we wanted to prove, that AP bisects angle A, that we already saw because this triangle was congruent to this triangle, and then these small triangles are also congruent to each other, so it gets bisected here. So thus we have completed the proof for point number 3 as well. Now let's come to point number 4. Point number 4 asks us to prove that AP, so this line AP is the perpendicular bisector of BC. The perpendicular bisector of BC. So what is the definition of perpendicular bisector? Okay, let's zoom in here. So perpendicular bisector means a line. Okay, so this line will be a perpendicular bisector of BC if point number 1, it is perpendicular to this BC, and if it divides this BC into two equal parts. Okay, so two equal parts is already shown. Here it is. Okay, we already have this thing. BP is equal to CP. So BP is already equal to CP. That is already shown. So AP definitely is a line bisector of BC. But the additional information that we want to prove is it's a perpendicular bisector, which means this angle has to be 90 degree. Now again, that's a very simple thing to prove because we already have this. Okay, BDP is congruent to CDP, right? So I'm going to zoom in here and just make a small proof here. Okay, first of all, let's remove these things now. This is not needed. This we have to prove. Okay, so the thing that we know is BP is equal to CP. Okay, and another thing we know is we have. So I'm just going to write it. We have triangle BDP as congruent to triangle CDP. Okay, therefore angle BPD is equal to angle CPD. Okay, I'm going to use a highlighter. This angle BPD is equal to angle CPD. Okay, however, we know that summation of two angles on a straight line, okay, is equal to 180 degree. So however, angle BPD plus angle CPD is equal to 180 degree. Okay, let me just draw a demarcation here. This is disturbing. Okay, okay. Why is this so? Because these are straight angles. So let me just write the explanation. Because these are straight angles. Okay, angles which are on or which lie on a straight line, their summation is always equal to 180 degree. So this is my straight line. This is my straight line BC, and this is one line on that BC horizontal line. So these two angles, no matter what, their summation will be equal to 180 degree. So BPD plus CPD is equal to 180 degree. However, BPD is equal to CPD. Okay. Therefore, I'm just going to say, so okay, we can say let angle BPD be equal to angle CPD let that be equal to x. Okay, let that be equal to x, and therefore I'll get x plus x is equal to 180 degree. Okay, and therefore we will get 2x as equal to 180 degree, and therefore we'll get x is equal to 180 divided by 2, which is equal to 90 degree. Okay, thus the measure of these angles, okay, let's use the highlighter. The measure of these angles BPD and CPD is equal to 90 degree. So let's come here, let's zoom in. Yeah, so these highlighted angles are in fact equal to 90 degree. I'm going to make a note of it. This is 90 degree and this is also 90 degree. Okay, thus we can very confidently say that this line AP is a perpendicular, because it's 90 degree, perpendicular and bisector, because at point P this line BC is divided into two equal parts. So it's perpendicular and bisector to this BC, and hence we prove point number 4, which asks us to show that AP is the perpendicular bisector of BC, and that is also done. So in this way we have shown step by step all the 4 things that we were supposed to prove in this question. The most important thing is, in every step when we prove this triangle is equal to this triangle, we take some conclusion out of it and use it to prove this. Then from this proof we get some conclusion and we use it to prove this. So this is like a follow up parts of the question, where from the previous proofs we use some piece of information and prove the next point, then again we use some piece of information and use the next point. So that is very important. You have to be a little bit alert and a little bit focused while solving this problem, that how step by step, okay, one proof leads to other, this proof leads to this proof leads to this. So that was a little bit difficult or a different thing in this problem. Otherwise it's a very simple and straightforward problem.